Hello, this is Karl Jones again, the old retired chemistry teacher. I'm finally making some more videos. This is the first one, and maybe I'll make 2 or 3 pretty quick since it seems I've got myself back in the mood again. I'm going to start calling this series Chemistry According to Karl. So if that really upsets you, I'm really sorry, but that's what I'm going to call it. So this is episode 2, and tonight's reaction is called the chemistry tree, and we're going to be making a Christmas tree sort of out of a chemical reaction, and it's going to look like sort of like a flocked tree when we get through, I hope. And we're also going to do some of the measurements that go with it too, so if you want to learn some chemistry from it other than just interesting reaction, you can do that. So we'll stop here just for a second and get a closer view of the starting point. So hang on. Okay, so these are going to be our reaction chemicals here. We're going to have silver nitrate, 10th molar, and we're going to have this little spiral of copper wire as our base for our chemistry tree, or Christmas tree. And we're going to weigh everything that goes into the reaction and comes out of the reaction. So the first thing I'm going to do is I'm going to reach over here and I'm going to weigh my copper, and I get 2.67 grams. So I'm going to stop and write that down. All right, the next step is to add our silver nitrate to the beaker. And after the silver nitrate is added, we will place our copper tree inside. All right, now this is going to take a while, so I'm going to have to stop the video here in a little bit and come back to it in just a while. So we'll see how it looks after a bit of time as we go along here. So hang on there. It'll take a while, but we'll get there. Hang in. I forgot to set my timer as we got started. This is about 5 minutes in, so I'll start a timer now. You can tell that things have happened inside the beaker. It looks different. I'll see if I can zoom in a little bit without messing up my picture. Yeah, looks like I can get a little closer. We'll be back in just a few moments then, like about 5 minutes. Bye. This is how it looks now at 10 minutes. Remember, I started the timer 5 minutes after it really started. Notice there's a little bit of color change in the beaker, and the copper wire just doesn't look quite the same. We hope for more change as we go. Well, here we are at 10 minutes and 30 seconds. Couldn't get my hands to work the remote just right. Things are going along pretty well. Of course, this is really 15 minutes and 40 seconds because, you know, I started the timer late. Remember that? Yeah. That's the way it is when you're not that good at making videos sometimes. Okay, we're at 20 minutes now, and that's my stopping point, I guess, for letting the reaction run tonight. Now, I used to do this lab every year with my students at Christmas time. Okay, so I need to get now I've got another beaker back here. I'm going to try and get my chemistry out carefully without ruining it so that you can see it. Then I'm going to put it back in this other beaker because I want to catch all that shiny stuff in the other beaker, and I have extremely good suspicion that shiny stuff is actually silver. Okay, so we don't need the timer anymore. So I'm going to do what you do on or about New Year's Day, you get rid of the Christmas tree. Oh, it's sad. You've had the decorations up and you enjoyed them. So I want all the silver, get it all knocked off of the copper here. And I'm going to go get me something to help me knock some of it off and get it to dry a little faster too, and get some acetone. Okay, we're going to try squirting a little acetone on here, see if we can get some more of that silver to come off. Whoa, missed the beaker. I've still got some silver here. I may have to turn off the video and work on that just a little bit. We want to make sure we get it all, at least the best we can. Okay, the next thing I'm going to need to do is to get the mass of a piece of filter paper, because I'm going to have to filter that acetone and silver mess so that I can get as much of the silver as I can get. Looks like my filter paper is 0.53 grams. I'll need to write that down, so we'll do that. All right, and we're going to need to, we'll go ahead and, while we have the balance turned on, we'll go ahead and find the mass of our copper after the reaction. And looks like we have 2.49. Now, when we got started, this was 2.66. So some of the copper is somewhere else. And the somewhere else the copper is over here in this beaker. And we can tell that by two ways, and we'll probably try both of them here tonight. First way is that the water solution over there has a very nice blue color to it, and that's a very characteristic thing for our copper ions in solution, to have a blue colored solution. So we know pretty darn well if that's where the copper is. But we'll test it another way in just a minute. All right, so I'm going to set up to do the filtration here, and we'll do that next. I'm going to move the balance out of the way so we can see what we're doing with the filter paper and the funnel. Bring the funnel into view here, and an Erlenmeyer flask. Okay, I'm gonna go ahead and show you the filter paper. We need to fold the filter paper. I'm going to fold it twice, and you're going to see that there's 4 little pieces of paper there. I'm going to pull 3 of them together and leave just one. So we'll have a cone, and we'll set that up to do our filtration there. And I'll use a tiny bit of acetone here to wet it down and get us started. Let's see if I can get it to do it a little bit better here. All right, so we're about ready to try and get the silver from the beaker. I'll move it to the front for a moment. There's quite a bit of silver collected here in the bottom, and that liquid there is acetone I used to help wash it off the copper wire. So I'm going to stop the video for just a moment here and kind of get things set up again, if I can find the button. I'll move in behind here so maybe I won't block the light so much. We don't have great light here because I got started late tonight. I'm having to work at night, so I'm going to decant the silver acetone mixture through the filter paper. And we should catch the silver on the filter paper. And since we weighed it dry, we're going to have to let it dry a little bit so we can weigh it again and find out how much silver we've added to it. I'm going to rinse down the sides of the beaker so we can get some more of the pour the silver down in the bottom with the rest of it so it didn't stuck on the sides. We'll have to do that again at the end. And while that's filtering, we'll wait a little bit and I'll finish up the filtration. Okay, this is a quick look at the setup as we're getting down to the bottom part of on the measurements and everything. Filtered the silver out of the acetone onto the filter paper, and it's drying there. And the silver and acetone were in the beaker that looks pretty clean on the right. So hopefully we got all that. And then we still have the copper, presumably copper solution to test in the back to make sure that it truly is copper. So we'll wait a little bit for the paper to dry, and while we're doing that, I may get ready to do the test for the copper solution. Okay, we're going to give this a try. The beaker contains the copper nitrate solution. I put in some wood splints and soaked them in it, and I've got a Fisher burner going here. And if there's enough concentration here, which there may or may not be, we'll see, we should be able to see a change in the color of the flame. Yeah, you see some flashes before it decided to catch fire, which is not unlikely. We had a few flashes of, there it is, it's really nice there. The copper color is a blue-green color in the flame, and that is confirmation of the fact that it is indeed copper. Okay, so now after I've given the filter paper and silver a good bit of time to dry, I'm going to punch it on up here on the balance, and let's get the mass and see how everything turned out. I'm seeing 1.22 grams. So I'll make record of that, and then the next little video segment will be the calculations if any of you are interested in it. If you're not, you can stop anytime, of course. Okay, we're going to try the calculations here. I'm going to use my scupula or spatula as a pointer here. The first thing we did is we found out how much the copper weighed before the reaction. That was 2.66 grams. After the reaction, it weighed 2.49 grams. So that told us that we got 1.17 grams of copper that was actually used in the reaction. Now, if you want to turn the copper grams into copper moles, which is what we use in balanced equation, or moles, or representation of moles, scoot this over just a little bit, 0.17 grams of copper divided by its molar mass of 63.5 gives us 0.0027 moles of copper. We'll need that later. All right, now we're going to go down and look at the part with the silver. All right, so the silver and the filter paper together, after we dried it, was 1.22 grams. The filter paper by itself was 0.53, so we subtract and we get 0.69 grams of silver. Now once again, we have to compare moles to moles, so we have to do a conversion, and we have 0.69 grams of silver, and the molar mass of silver from the periodic chart is 108, rounded off to three figures, and we get 0.0064 moles of silver. Okay, so we have the moles of silver and the moles of copper. So to find a ratio, we can divide through by the smallest of the two amounts of moles, and that's the copper moles. It's smaller. So 0.0027 divided by itself gives us 1, and 0.0064 moles of silver divided by the same smallest value of 0.0027 gives 2.28. So that tells us that if we round it off to closest whole numbers here, which is convenient for this experiment, especially since we only had a centigram balance. We have 2 moles of silver, like you see here, for every 1 mole of copper. All right, well, that helps us balance the equation. So I'm going to turn the page, fumble around, and then we're going to figure this out. So let's see, we had for every 2 moles of silver, we had 1 mole of copper. So I'm going to put a 2 coefficient to represent the 2 moles of silver. I don't use a 1, it's just understood for the copper. So let's see now, that gave me 2 nitrates over here. So I'm going to need 2 nitrates over here, and I took care of that. The coefficient for copper, I'm going to go ahead and write the 1 in, even though you really don't when you write a balanced equation, it's just understood. And if we have 2 moles of silver on the left, for the reactants, we have to have 2 moles of silver on the right. So we have the balanced equation. We balanced it all out. We learned a little stoichiometry. We saw a silver Christmas tree get formed, and I hope you all had at least a reasonably good time, at least up until the calculations, of course. Merry Christmas.